Hello students, today we are discussing the most important questions of chapter current electricity. Now these are the questions which are frequently asked in the board examination. Let us discuss these questions in detail. Now this question is, derive the relation between current density, symbol is J, and conductivity sigma of a conductor. Now this figure, whatever we have shown here, you can see this figure consists of a high potential means positive. Here I can write high potential and this is called as a negative. The length of the conductor is there. You can see a length of the conductor is L. L is called a length of the conductor. The field is applied along this direction. And you can say this is a conductivity is along this direction now. The current is flowing along this direction. This arrow mark shows here. And delta V shows the length of this one, that is called as a V. The small voltage drop across this one can be divided by this. And this is your whole batteries here. The equation E shows that is a vector J is equal to sigma into E. Now where vector J is, this is a current density, and sigma is conductivity, and this is called electric field. Now this is one of the most important relation is there in current electricity. Let us derive this equation step by step. Let us first know the requirement of this one is Ohm's law. The first we know this is called as a Ohm's law. You can say this is a very first law in our current electricity. This is called the Ohm's law now. The Ohm's law is written as V is equal to, this is I into R. Now here you can see, I can write from this one, I is equal to V upon R. Now this is a Ohm's law. The Ohm's law written in the current is equal to voltage upon R. When you're talking about resistance of a conductor, this is directly proportional to length, inversely proportional to the area of cross section, and when you write this is equal to, then what it comes to in this one, this is called as a rho. Rho is called as a proportionality constant. Now I can call this equation number 1 and you can say this is equation number 2. You can substitute the value of R in above this equation, that means I is equal to, therefore I can write here, this becomes I is equal to V divided by R value is rho L upon A. This is R value now. Further you can simplify this one, this becomes as VA divided by rho into L now. Now this expression what we are getting now, this is I is equal to. Now further this equation we can modify this equation now. How to modify that means this I can write, this is I is equal to, right here 1 upon this is rho, and this happens to be V, this is a area cross section here, and this divided by L now. This is I is equal to. Again this what is 1 upon rho is equal to, it is sigma. Then you can write for example other factors also. The other factors becomes like this. Now this factor I will write it as, or I can write I, this is I upon A, and modify that equation. I am writing this is 1 upon rho, and here I can this is V upon L now. Just to check it up, what happens now? This is I is there upon O is there. Now this equal to, this is a current density J now. And you can say 1 upon rho is there, this is equal to sigma. And voltage upon length is there, right? Voltage upon length, whatever may be is there, that means V upon L is there, this becomes E now. Substituting this, J is equal to I upon R, I is equal to J now. 1 upon rho is equal to sigma, and V upon L is equal to E now. You can write above this equation. Now this big equation becomes J is equal to, this is sigma, and this becomes as E now. Now this is our required equation is there. Our required equation is, that is a current density J is equal to conductivity multiplied by the E. E is the EMF of the battery now. In this expression, you can further see, you can write this expression like this now. This is our final equation. This equation was written in this fashion now. J is equal to, this is your sigma, and this is here. Now you can say what the J is now. Now here J is nothing but that is a vector J now. It is called as the current density. This is called as a current density. This is symbol for current density. Then you come for this one now. This is our sigma is there. This is conductivity of the wire now. Now this becomes conductivity of the wire. You can say this is conductivity, and you know what is E is equal to, no? Now this E is equal to, we can write in such a way that is a electric field. I can call this as a electric field. Electric field set up in the wire or the conductor. That means now up to this you can very well describe what is a J is equal to sigma into D, and you can say that this is one of the important derivation is there. And now next we can go for another derivation. Another derivation is expression for conductivity of a material in terms of relaxation time. Now here it comes the conductivity now. What the formula comes here? This formula comes for sigma is equal to. These are the number of electrons are there. E is a charge of the electron, tau is a relaxation time, and m is the mass now. Now this formula we wanted to derive here. What is this now? Conductivity. You have written this is a conductivity here. Conductivity of a material in relaxation time. Relaxation time, this is tau now, relaxation time is there. This is, you can say, conductivity in terms of relaxation time. Let us derive this one. Again we are using the conductor which is having the electric field E. J is a current density now, and its voltage applied between a high potential to low potential, and potential difference is given by delta V here, and del is the length of the conductor. Let us first consider the equation that so far I discussed here. Now that becomes J is equal to sigma into E now. This is the relation just now we have derived here. Now this relation we wanted to modify. You can see this is a sigma is equal to, this becomes as J, this is divided by A. This can be divided as sigma upon J A. But you know this J is equal to I upon A. Just now we have done, now this becomes I upon A. The another relation is that is a, you can write J is equal to here, and this sigma becomes I numerator, and this becomes as A into E now. This is again one modified equation is there. You know this expression also, but we have got current density I is equal to, this is written as N A, V is the drift velocity, and E is the charge now. This is another equation we are having now. Now substituting this, the sigma is equal to I is equal to N V V D E now, whole divided by A divided by E now. Now this A gets cancels. It has been cancelled now. That means sigma is equal to what you can write now. Now this becomes as sigma is equal to, this is N drift velocity, then E divided by capital E now. Now this is the expression. Still we need to modify this expression now. Let us modify this equation such that now this becomes as sigma is equal to N, I am writing this is a VDE whole divided by this was A. Now what I am doing for this one now, but we know that is a drift velocity here, V drift velocity now. Now this becomes as this is a tau divided by this is m now. Substitute in the above equation, this becomes sigma is equal to N, this is, you can write here VD is equal to E, then E tau another E, and this becomes as m into N. This E and this you cancel, this clearly becomes N, this is E square tau upon m now. This is our required equation is there, N E square tau upon this is m. I say this is one of the most important equations is there now. This is used in higher studies also. That means when you go for the current electricity or electric regarding you study, the charges also study now, the conductivity is given by this equation now. Now this is one of the most important videos there where you can practice these questions now. I assure that these questions are very important in your studies of the Pius examination. That is, thank you one and all. ಅಭಿಲಾಷ್ ಏನಾಯ್ತು ನೋಡಿದ